Yeah, because the origins of this work have to do with foundations of quantum mechanics for the minds in some respects. A couple of about them, I decided not to talk physics in this talk, but I'll leave them here. You'll have the slides. You can look them up if you want, where the idea was to take measurement as a very fundamental entity. Maybe that's the reality that we actually see. And if not, it can be like a virtual machine, as computer science would say, that hides away the details of what collapse of wave function is, etc. So this is like a mathematical formulation of Wheeler's idea of it from bit, where ultimately, towards the end of his career, he defended that manifestation of reality is the creation of information. That's like all there is. This raises a lot of philosophical questions, which I'm not going to get into. Now, an adaptation to Qualia is something that I wrote at some point, because the idea that this measurement has something to do with consciousness has been around us well, since the early 20th century. So I decided to take this model and think, okay, instead of measurements, let's see what happens if we think of these things as qualia. And yeah, you can import it, but then some questions arise. And it's these questions that prompt me to give this talk, because I think there's an intersection with, well, a lot of stuff that we've heard this week. So the aim for today is to relate this to the qualia structure paradigm and IIT. So I'll start with some basic concepts. Somewhere along this school, somebody talked about old school notion of qualia. I don't know what that means, but I'll give you the oldest school notion of qualia, which is the one I know, which is from 1929 by Lewis, a philosopher and logician, who basically said that qualia are the inherent or intrinsic qualitative characters of a moment of subjective experience. But also he did something else, which is defined the notion of a pure concept, which is a meaning which we can actually talk about and communicate to other people. This is interesting because at about the same time in the early days of quantum theory, Bohr was adamant that, well, results of physical measurements have to be communicated using classical physics, so classical logic. So there's a parallel here. And so I decided to start my talk by describing exactly what kind of logic is that which rules the pure concepts. And for that, I'll borrow a concept from computer science in the 80s, where people talked about a logic of finitely observable properties. That means properties which can be observed using finite resources, like finite time, finite energy, finite everything. Now, an algebraic formulation of this is that you take a set L of formulas and some operations on them, which are the usual ones in logic: conjunction, phi1 and phi2, etc. They are true if all of them are true. And you take arbitrary disjunctions. Now, there's an asymmetry here. The finite conjunctions, in principle, to be verified, have to be verified one by one. And unless you have a Zeno machine that verifies infinitely many things in finite time, then you can only have finite conjunctions. Whereas for a disjunction, if, well, it will be true if at least one of the disjuncts is true. Okay. Now, the axioms will include distributivity, and intuitionist logic is compatible with this. You can interpret it and can formulate it in this way, but the distributivity rules out immediately all sorts of quantum logics. Now, the set L is equipped naturally with a partial order, where the conjunctions are infima, so the greatest lower bounds of a pair of elements, and the disjunctions are the suprema. And the order is an implication. So phi less or equal to psi means that phi implies psi. You can think of this in terms of classical logic, saying that if phi is true, then psi is true. Or in terms of intuitionist logic, that means that you can, using phi as a hypothesis, you can prove psi. It's a different thing. So this algebraic structure is called a locale. It's got a greatest element written 1 and a least element written 0. An example of a finite locale is this thing. You got the 0 at the bottom, the 1 at the top. The lines are less or equals. You've got 3 atoms, so 3 elements which are right above the 0, and then their disjunctions. And at the way you have at the top, you have the disjunction of everything. This is isomorphic to the power set of a set of 3 elements. Take set A, B, C, take all the subsets, and you get exactly the same structure where now the lines are inclusions. In fact, this is a topology on a space with 3 elements and a special topology which consists of all the subsets. In general, a topological space is a set equipped with a collection of so-called open sets, where the whole space is open, finite intersections of open sets are open, and arbitrary unions of open sets are open. And these topologies always form locales, with the order being inclusion. And there's a very nice relationship between logic and topology, because any theory propositional intuitionist logic can be identified with the topology of a space.
Which is also thought I dropped the law of excluded the law.
Just drop the quantum. So now, a typical example of space, which is the one we are familiar with, is that of a so-called Hausdorff space, such as a metric space. These are the spaces which we are familiar with. We look at a table and you put 2 points there, and we can define 2 little circles around them, and those circles are disjoint. So you can separate points strongly. All of analysis in geometry usually uses such spaces. Computer scientists don't. They use strange spaces, and I will use strange spaces here as well. So, and those are the spaces of Qualia. Now, the topological space of Qualia will consist of a set of Qualia equipped with a topology whose open sets are the pure concepts. So the pure concepts will form an intuitionist logic, and I will choose that to be the topology of Q. There's no need for more. So the open sets are the finitely observable properties. One should think of Q as containing all the possible qualia in the universe. Everything happening with humans, chimps, cows, ants, nematodes, maybe plants, or who knows what else. So there's no sense here a priori about who are the owner of these qualia. Is it Bob, Alice, or...
So every possible experience.
Every possible experience is in Q. Yeah.
Is it finite? Does it matter if it's finite?
Well, I'm pretty sure it has to be infinite. It should be, well, or maybe, the universe is very big, but it's, well, I will not, I will invoke the whatever amendment not to answer that question. Please.
Is it the kind of intrinsic, or is it shared kind of reality for everyone?
We'll see. So if you just say Q as a bunch of qualities of subjective experience, it's just what it is. It will be glued by the topology in some sense. And the idea is that the entities, the conscious beings, whatever, they will emerge within this space. Now, the meaning of a qualia alpha belonging to a property U is that U is a possible finite physical imprint which follows the experience of that qualia. For instance, if alpha corresponds to seeing a flash of light, then U can represent any of the following reports. The light was red, the light was intense, the light was brief. These are things we can, but the experience was just indivisible all at once. Another example from yesterday's talk was you have the experience of a dog, but you can have more specific experiences of the dog rotated 30 degrees and the dog upside down, etc. So all of that structure that we saw yesterday is buried in here. For nonverbal subjects, U could be any synapse modification following alpha. So any physical change that was caused by a moment of experience. Now, yeah.
We define the default, right? You're defining default.
I'm saying what the topology is. Yeah, what's the meaning of the topology? Yes. Well, you see something blue and something changes in your brain. That's a physical imprint. So there's a causal relation between having an experience and having a change of physical state. So you can report it or not, but it will be there. I mean, that's it. So at this moment, this looks like a dual theory where you have the mental stuff on one side and the physical stuff, and the mental stuff is affecting the physical stuff. But it's also the other way around.
So you are starting from then on.
Yeah.
So that's a consciousness part.
Yeah. Although you see the open sets are there as representing the physical properties. So it's an interdependent model. The two things are evolving together. Please.
So I'm curious to me about the physical changes during the experience or right after the experience, because the reports follow the experience.
Yeah, I mean, in principle, I would consider any change that occurred immediately during to that. The report can be a way of a second order verification of what changed.
Okay, so can concern the
but-
state of the substrate.
Yeah, but it's also a physical imprint. I mean, you have a physical imprint, which is something happening in your brain. Then somebody asks you, what did you see? And you write down on a sheet of paper. That's also a physical effect. Now this sheet of paper is dirty with some stuff on it. So any such thing is a physical imprint.
So, but as we discussed, we really want to separate the response, talking about experience, pushing a button from the actual response, right?
Yeah.
So is you always associated with some sort of response, or is it just physical substrate of an experience in you?
By response, you mean a report?
Report, yeah.
No, it doesn't have to be associated with a report. So an end who experiences something will have some change of physical state.
The you is so you encompasses all the space of subspace of any experience in Q.
Yes. Yes.
But you is phenomenal, not physical, right?
U is physical. The idea is that U is physical. U is a physical property, something in the physical world. The phenomenal is in Q.
So there's a one-to-one bijective.
It's not bijective, but it's interdependent. There's a relation there.
Sorry, if you say the light was red.
Yeah.
I mean, you can represent that the light was red. Isn't that phenomenal? Isn't that?
Can represent.
Well, that goes to the idea that, okay, if you store a concept in your brain, now you have the concept of red, you can evoke it. You can remember what red was like, and you have an experience. It's not the experience of seeing red, it's the experience of remembering red. So there will be, and if I get to the end of the talk, a map trying to describe semantic memory, going from the concepts to the qualia themselves. So there's a lot of interaction that can take place between the topology and the actual space. Now, there is automatically, once you have a topology, there's an order between the points. If you write n alpha for the set of all the open sets that contain alpha, we write alpha less or equal beta if the number of the set of open sets containing alpha is contained in the set of open sets containing beta. So beta has more potential properties than alpha. Now, in terms of qualia, that means that beta, which is greater, has more potential properties, so it is less determined. It's like I've seen light, and the light could have been red or blue. Whereas if alpha is more specific, I mean, I saw red light, it could not have been blue. So it's only in the open set corresponding to blue. This is a little weird. Yeah, please.
Sorry, I apologize. I want to make sure I don't get lost.
Okay,
So use an open set, but is it an open set in a topology queue or is it not in a topology queue?
so it's an open set of the topology of Q.
Q is an open set.
Yeah, yes. Thanks for the question, yes. So this is a little subtle, this order. You can find similar ideas of specificity in computer science, for instance, which look different. Something greater has more properties because more properties have been computed during a computation. And this thing has all these properties. Now, beta being larger, it doesn't have all the properties at the same time. They are potential. It could have been red, it could have been blue. It cannot be both red and blue. That would be impossible. Well, the first question, I mentioned this in one of the afternoon sessions, is, well, if such an order exists, I mean, can you devise a psychophysical test to actually see if people have this order experience in their minds? Now, one axiom that this comes from the measurement spaces, from the spaces of measurements, and I will use the axioms that I had there, and we'll see how they fit in. One of them is that if two qualia have exactly the same open sets, then we impose that they are the same. This is saying something strong. It's saying that, well, if the two qualia are not distinguishable by any physical properties, I mean, you'll never be able to tell them apart, then why say that they are different experiences? This is sort of intuitive. I mean, if I have two different experiences, and if I notice that they are different, that means somehow that will leave some imprint in the brain, which will tell them apart. So this space has this property.
Supervenient.
Is it called supervenience? Okay, thanks. There's another one, but now, and this one is very strong, which is these sets and alpha, they can be characterized logically in terms of the connectives of the logic, the infinite suprema and the finite the finite conjunctions, and any such set, we force that any such set has to be an n alpha for some alpha. So we can think of these sets as like sets of properties that look really like the properties of some qualia. And we want that when that happens, they are actually the properties of some qualia. So there are no ghost qualia in here. This is a very strong axiom.
What is that? Ghost qualia?
So these sets and alpha, they have some they have some algebraic characterization in terms of the logic, okay, this intuitionist logic that I was describing in the beginning, and so you can describe them abstractly without reference to any particular qualia. So you can form such sets F, just taking open sets of the topology, and so they will look like the kinds of sets that you have when you form an N alpha. And we want to say that whenever you have such a set, there's an actual alpha of which that set is the N of alpha.
Very strong.
It is very strong, but it is very strong.
Subset in hopes.
Yeah, yeah.
Still representative of what? I mean, borrowing the language from functors.
Yes, it's like, yes, that's true. Yeah, all the functors are represented by an object somehow. Yes. So this says that all the knowledge that you can have about a putative qualia determines an actual qualia and does so completely and uniquely. Now, the role of this is the same as Yuneda's lemma in the qualia structure paradigm. It says that you can know everything about a qualia just by looking at its properties or relations to.
You need the uniqueness of our qualia.
Yeah. Yes. Oops. So in terms of Mary's room, this means that if you know all the properties about alpha, then, well, you have uniquely identified alpha. But it doesn't say that you can experience alpha. In practice, these are infinitely many properties, so you'd never get there anyway, but I don't, yeah, please. Yes.
All the knowledge was all that we essential fail alpha completely in
Oh, you have to speak louder, sorry. slower.
Of the knowledge about some Qualia, that you might say in your mathematical framework, and you say that's equivalent to Genera's lemma. I think that one of the values of Genera's lemma, at least in the Qualia structural program, is that first it tells you, yes, the Qualia can be completely determined, but also it tells you how, very precisely. Like if you map every relation, then
Yeah.
you have it, right? But here, your condition is you have to have all the knowledge about one specific Qualia. My question to you will be, how does it look like, all the knowledge of, how many knowledge, can you give me an example of the knowledge of the remnants of red? What knowledge do you have of that?
Well, abstractly, it's all these open sets, all the knowledge about the redness of red. Okay, you saw some flash of light. You can say it was red. Well, it was light red. But that quality may have some other feature. It could have been intense red. It could have been short-lived red. It could have been a lot of things. I mean, the redness of red is not very well defined. I don't know what the redness of red means.
Okay, so when you say all the knowledge, you mean like all the experiences which contains red?
Yeah, for that particular quality, you could have all the properties that identify that one. Okay?
So your idea is Q is all possible subjective experience. Q.
Yeah.
And but the topology of Q is determined by physical one.
Yes.
And this correspondence is very strongly tied by these axioms.
Yes. 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 So this makes the two worlds interdependent. I don't think maybe we can talk about this later. I don't think my answer was satisfactory, so somehow, but
It's not necessarily in there. So
not necessarily what?
when you say it's not necessarily the same, but it still could be same thing. The last sentence.
Oh yeah. Who knows?
But sometimes I have a conflict. So alpha is an element in blue, right?
Alpha, yeah.
But sometimes you talk alpha in Q.
Yeah, alpha is an element of Q always. And U is an open set, so it's a subset of Q. So those.
The U is a physical property.
Yeah, so those subsets of Q are the physical properties.
Well, corresponding to physical. So it's like an idealism.
Sorry, it's
Idealism. Within Q, subset of that Q is U.
yes,
Yes.
yes.
You are the open subset, or you are open subset of Q.
I see.
And the open subset.
Yes.
I see that if you say that actually probably makes sense.
Okay. Yeah, it's very important that all these ideas well, get clear now, because otherwise none of this will make sense. And yeah.
But Q is first, right?
Yeah, Q is first. Q is a whole set. The U's are subsets, which are the physical properties. Yep.
Physical thinking, like if I see the red light, and the light was not blue, the light was not green, can be a physical thinking or not?
Sometimes. But you see, the whole spirit of this is a kind of intuitionist logic. It's not Boolean. So it's affirmative. It's when you see something, you know you saw that something. This may or may not exclude other things which are disjoint. If you think about the topology of this table, and you have a circle without boundary, that's an open set, you can know for sure when a point is inside, because it will be always a finite distance from the boundary. If you look close enough, you'll see, oh yeah, this is inside. If you have a point on the boundary, you'll see, well, is this inside or outside? You look closer and closer, and because I'm God and I know that I placed it on the boundary, I know that no matter how close you get, you will never be able to decide. So it's undecidable. So that means that the complement of an open set, which is a so-called a closed set, is not part of the topology. So it's not one of those finitely observable properties. So in general, this is not true. But of course, you can have disjoint open sets. And so being in one excludes being in the other. Okay?
Here's some formula. So, if I try to simple view, maybe on the point on the edge, I can't say this is inside the table, but this is also outside the table. So if I want to,
Yeah, if you have a point which is definitely outside that circle, that means that it's contained in some open set, which is disjoint from the other circle. That means you have two properties whose conjunction is 0, and so they exclude each other. So, but that says that in order to separate 2 points, you need 2 physical properties which are actually mutually exclusive, and these are open sets. But the exact complement of an open set is not an open set in general. Okay?
Not only the union should be joined, but also the union should be everywhere.
Sorry,
The union should also be everywhere.
the union should be everywhere?
Everywhere. So should
Oh,
be perfectly copy, then you would have
the union. Yeah, the union of all the sets, the open sets, is everything.
not all the two. So these two opens up. Yeah.
That's also an open set. Yes. Okay, maybe okay. I'm not understanding. Okay.
You suppose that this open set, not closed set.
Yeah.
I understand the reason of the intuitionistic logic, but can you explain why the conjunction is finite, allowed finite, but the disjunction allows for this closed space?
Okay. Think in terms of the open sets. So if you want to, if you want to assert that the point is in a collection of open sets, you can verify that one by one. And the intersection of all those open sets is actually an open set containing that point. If you try that for infinitely many open sets, the intersection can be just a point, which is no longer open. It's not in the topology.
I know, but
yeah, I know, you know.
Why this is suitable for the Qualia stuff? Qualia, how to say, the infinite. You think the infinitely many disjunction. You need some pure concept.
So that goes back to the idea of the logic of observable properties. That conjunction has to be verified one by one, and you have to verify all the disjuncts using finite time and energy. So it's the physical constraint will say that infinite conjunctions should be left out of the picture. Whereas disjunctions are okay. If you want to verify A or B, just have to verify A. So, or A or B or an infinite number. So that asymmetry is the very abstract way of saying that we are dealing with finitely verifiable physical properties. Okay. All these conditions define a space with a name. They're called sober. And because you'll be wondering, why are they sober? Because the mathematicians have a sense of humor. And when they define sober as these spaces are not drunk, because you see, if the potential points, which are these collections of sets that look like n alphas, they have to become from a single alpha. You cannot see double. And you cannot imagine things that are not there. So that's the piece of mathematical humor culture. Now, the specificity order, because of this sobriety, is very, very strong. It is complete for things that look like computations inside a space of Qualia. For instance, if you have an infinite sequence like this one, and it doesn't stop, alpha 1, then alpha 2 is greater, et cetera, there will be a supremum. So there will be another Qualia, which is actually sitting above all of those, and it's the least one sitting above all of those. That is, one can think of this as saying, well, if we experience successively more abstract Qualia, there will always be a Qualia that should correspond to an insight, like an insight that, oh yeah, okay, there is something real at the end of this ascending sequence. And I think many insights in everyday life might be like this, like our sense of self, which results from integrating many things. I mean, it is bubbling inside of us. And at some point we think, yes, well, I am real, which can be slightly debatable, but yes. But we have this feeling. So of course, there's a lot of neural machinery for this or cause-effect structures and stuff. But in terms of this abstract structure that I'm presenting, this is the result of a computation, which is like such an ascending sequence. It doesn't have to be linear. It can be many qualia that evolve, but as long as two of them always have an upper bound in this set. And it doesn't have to be countable. It can be indexed by the real numbers. It can be a lot of stuff. So of course, these properties of Q are idealized. I mean, now you're wondering, I mean, do we have that power? I don't know. I mean, does a cockroach have the power to have strong insights? Who knows? But I don't think so. But so a given sentient being may fail to possess the cognitive ability to attain various kinds of insights. But what this Q is a kind of mathematical canvas where in this language, I'm putting all the desirable features that quality structure might have. And then we'll see what it means for a sentient being to be able to satisfy some of these, please.
But only something like higher up in terms of ranking would be considered something, you know, all these like qualia are experienced.
Yes. Why the supremum should be considered something real? Are you asking in terms of a model of consciousness like IIT or?
About the ones that what is sequence?
Yeah, exactly, the sequence.
Yeah.
So it's not like you're saying that a really high alpha, like anything called like medium or something corresponds to sense of self, right?
Mhm.
That's what I'm saying. But is it correct? Like a sequence of alpha one to the giant sequence corresponds to one set.
It will have one particular end always. It cannot just go up to infinity. It will always have something that represents it at the top, like a feeling what it is to have computed that even infinite thing. This is just a mathematical property that I'm interpreting. So
that kind of sequence kind of thing corresponds to something real.
yeah.
Then probably the opposite of the thing that you are asking is probably something that the finish some finite sequence. Why does it not feel real?
Oh, it would feel real. I mean, if you have a finite sequence of alpha 1, alpha 2, these are very experiences. They are all real. If you stop, you stopped. What I'm saying is if it never stops, somehow there should be here the equivalent of a feeling that there is something where it will stop, even if transfinitely. So it doesn't stop infinitely many steps. It's like an intuition. Okay, this is, mathematicians have this. You prove things by mathematical induction. And that gives you a feeling that something is true for the whole set of integers. And somehow in our brain, this insight that something will be true after an infinite number of steps is formed. And you didn't go through an infinite number of steps. So there are ways to circumvent this. Please, Alex.
I started with this isn't this real?
Sorry?
I mean, that isn't this.
The self?
I have the supremum, right? So now there's another supremum to the supremum, and then there's another supremum.
No. I said that you might have a supremum, which is a sense of self. This would be like the greatest quality that I as a being have, the most abstract one, that I am me. Below that one, there could be I am me feeling a little anxious, or I'm me in a very good mood, or I'm me watching red light, or I'm me having an insight about a mathematical theorem, or I'm me getting into an argument. I mean, there are all these instantiations of me, which are more specific because now they satisfy certain properties which will exclude other properties. Whereas just being me potentially can be anything that I experience. So that would be the supremum of all my qualia. What I'm saying is that the sobriety property says that any sequence which is infinite, will have a supremum. It doesn't have to be that supremum. It can be another one. It can stop below that one. I mean,
Yeah. We didn't talk about this, but loss of sense of self is something that this structure mentioned, right? And in philosophy, over Nishida philosophy, Japanese philosopher, he also talked about basho, place, sort of roughly translated in English, the where you don't have even a sense of self, and that's like kind of a place that happens. Sort of.
Okay.
That could be even higher. I don't. That seems to be more like
yeah,
ultimate open space. Open.
that I would say is if my qualia have a largest qualia, which is my sense of self, I would say that that one will be something even higher, which, well, if I haven't experienced it, it's not one of my qualia, it's something even higher that can become my sense of self or somebody else's sense of self or something like that. If I experience it, which will be a mystical experience, then it becomes part of myself and I get transformed because now I have that experience. I think this goes along with what you said. Yeah.
Yeah, so very interesting. Discrete state.
Can you speak louder, please? Sorry?
Is it discrete? Because if you put no condition on the property, the property of being this experience, is it a property? Because otherwise, it's the Q is discrete. See, if we allow the property of being this experience, the same Q is discrete space.
No, no. That the largest alpha is not a property. It's not an open set. It's a point in the space Q. So it's an experience. It's not a property it's not an open set. Yes, otherwise all the points would be open sets and the space would be discrete. That's, no, I didn't.
Yeah, the property of the property that you use in
The properties of the properties.
yeah, for example, being red, why is this not being satisfied?
I'm getting really confused. I'm sorry. No, I'm trying to distinguish the property as something ineffable. Yeah.
Why not the property of being this experiment? For being this experiment, is it a property? Like being red?
No.
Why?
Having the experience is just having the experience. It's a. No, wait.
I think we push it at the extreme. I have the feeling that it's very close to this. Maybe I'm wrong.
No, it's not discrete at all. No, this it is not. So this is an axiomatic thing. So look at the points in Q as things which are ineffable. You just feel them. You cannot describe them usually in finitely many words or properties or anything. And then you have the properties, which are the finite things, the little stickies that you can attach. Property is any.
But I agree that the restriction doesn't the property, as you are doing now, in fact.
A property is, yeah.
We have a topology which is not discrete. So I was wondering what are the kind of property here, the meaning of.
So that,
Maybe if I understand correctly, there's two kinds of color. The concept of color, which is kind of property, and then there's the perception of color, which is kind of ineffable. What you mean?
perhaps maybe we should. Okay, when we get to this point where obviously we are in different perception boxes. And it's it's true. I mean, and I know that I'm here, and I have to thank now for allowing me to give this talk because I'm obviously not in one of the threads that people have been preparing to read. So this is very novel, and so it is okay that you're saying, okay, I'm not being able to fit this into any of my boxes. Yeah.
Yeah.
Yeah, okay.
We'll discuss that. Yeah, but I hope. Yes, we'll see. I hope it doesn't stop the meaning of the rest of the talk. But okay. Now you just have a little bit of more structure coming from measurement spaces, which is now for the quality themselves, there's a notion of disjunction, which means that given alpha and beta, there will be a special one, which is less determined in both, sitting a little above them. And because of this, the space Q is not Hausdorff, because any open set containing alpha has to contain something bigger than it. And so alpha and beta, any two properties of them will have a non-empty intersection. So the only Hausdorff qualia space would be a space with one single qualia. Not very interesting. Now this cannot arise in a vacuum. I mean, in physics, you'd say, yeah, well, of course you have a disjunction because of such and such. But now here, I'm trying to think that qualia are indivisible things. You have to experience them in an ineffable way. And so how do you justify this disjunction? And a thought experiment would be, say alpha is blue and beta is red. Well, you press a button a few times, and each time there's a flash of red light or a flash of blue light. And after a while, you see, okay, this is always blue or red. And you have a little insight, which is an indivisible experience. Okay, call that the disjunction. Mathematically, because you have this now, Q has supreme of any subset. So in particular, it will have a greatest element in Q, not to be confused with my sense of self. It's like the way greatest quality of all of them, which is compatible with any conceivable properties. So I like to call this the enlightened quality. It's just there being without committing to anything. Sorry? What?
Super I, primitive I.
Primitive I, yeah. Oh, yeah, okay.
Yeah, maybe also pure presence, or if you have so many dictators, they could tell you, oh, this is the state that is sort of the basic state, and then you put where you put all the requests.
Yeah, it feels like that, doesn't it? Yes. Okay, but it's there. It's just an element of the mathematics. So as I said, I'm trying to interpret these structures in this sense, just motivated by the fact that measurements and qualia seem to be associated for 100 years and nobody has been able to disentangle them. Certainly the original proposition by von Neumann, which was, well, you make a measurement, at some point there's a subjective perception of the observer, and then, well, this is nuts. I mean, John Bell in 1991 wrote a paper where he said, well, for how long did the wave function of the universe have to wait until the first collapse occurred? Did you need a single cell organism, or you need something more sophisticated with a PhD? So he was joking, but I mean, of course, this joke just tells itself. I mean, yeah. So this is trying to think of measurements and qualia as something fundamental, and let's see where it goes. It might not go anywhere. I mean, I might stumble into a philosophical brick wall at some point, but I'm still insisting. Yeah, okay. So that's good. Okay. There's another piece of structure, which is composition, which comes from, you can do an experiment and then another. That's a very obvious thing. Now, in terms of qualia, it's not so obvious. You do one and then another, and you need, if you want to have this composition, you need to have an experience of the composition. So you need some cognitive abilities. You need some memory. You need to have an aha moment. Oh, I saw two things. So this does not exist in a vacuum either. But it does convey a sort of notion of subjective time, because there's this idea that consciousness is extended in time. So qualia have a kind of duration, a sense of duration attached to them. And I think any of us who had anesthesia once has had this feeling that, well, you're told, okay, you're going to sleep, and immediately after you wake up, and then you realize, and I had this once, and I was saying, okay, when do they start? I thought. Then I realized they had stopped. It had finished. It took 2 hours, and so there was no time. There were no qualia, and there was no time. But that's interesting. It's like the qualia generate time. Alex, yes.
Qualia A and B that cannot be composited. For example, we have two colors at the same time in the same position.
Now this is sequential composition, or causal, one and then the other. Yeah. So it's now a non-commutative logic in a sense. This kind of conjunction is temporal. I happened to find a paper very recently by Mark Whitman and a bunch of people. I say Mark Whitman because that's the only one I know from a Zoom session once, saying that he realized that memory encoding for new information is correlated with acceleration of subjective time as you get older. So you encode information at a slower rate, and that sort of slows down your subjective time. So you have fewer qualia. So it's interesting. It seems to be an idea. I had some kind of anecdotal stuff to say, but running out of time, so I'll just carry on. So are there psychophysical experiments for detecting the formation of these disjunctions or compositions in humans? What are the cognitive structures that are needed? What are the causal effect structure that are required for these things to happen? Yeah. Yeah. So part 3, which is supposed to be the punchline, I'll go through it, is, okay, I've been talking about the whole space of qualia and occasionally talking about my qualia, but so what am I? So meet Bob. In quantum mechanics, there's always Bob and Alice. Bob experiences qualia since he's born, so he's got a subset of the space of qualia Q. That's his qualia. Now, this is a theorem, if Bob's cognitive abilities enable him to compute all those disjunction of qualia and perform the computations that exist in a sober space, then his space will itself be a sober space. That's debatable that Bob can do that, but let's assume that Bob is really smart, and so he'll have all of these things. Now I skip a lot of details, and if Bob cannot experience any quantum interference phenomena, which is translated to saying that his particular subset of qualia will be a distributive lattice, then his qualia will be a locale, and it will be isomorphic to the topology of a unique space, which I call S, which is not a space, it's just some abstract space. Well, it's a coincidence. So Bob's qualia can now be represented as being open sets of another space, which a priori is totally fictitious. And the points are nothing that Bob experiences, or are they? Let's look at this wall. Now, the way that Bob interacts with the wall is via photons. There are no infinite energy photons. That means that the spatial resolution of a photon is always a little blurred. So all the visual interaction gives Bob qualia that can represent at most open sets of the wall. Well, subsets of the wall, but so let's identify them with open sets. Now, the theorem guarantees that just by receiving this information about the open sets, there is that space S. And IIT suggests, as I learned from reading paper by Hahn and Tononi and seeing Matteo's talk, that this S. You see, that wall there is something that we think exists in reality, like this table, I think it exists. And I'm getting these photons that give me information about the topology only. And that allows me to know that reality, which is a table. Well, we can't dispute that. We are getting information which is somehow giving us something that looks like a topology, and our brain acts like a spectrometer that produces the illusion of the table. I don't know which is true. I'm inclined to thinking that the table is sort of an illusion. The experience of it is not. So, well, Q is not Hausdorff, neither is B, but S can be. And this is an interesting fact. Now, skip a lot more details. There is a theorem saying that if the experience of recalling pure concepts, so that's semantic memory, just recall something and have the experience of recalling them, that would be a map that goes from the open sets of Bob, which is physical properties, the concepts, to his actual qualia. And this should satisfy some natural properties, and I could argue what they are, but the conclusion is that with these natural properties, then S is a Hausdorff space. So it can be argued that because this map exists, then our illusion of a space will be Hausdorff space. That, for me, suggests an explanation why we seem to look at everything, and everything is so geometrical. Space is in manifold. That's how we see the world. I'm not sure the world is like that at all. I just know that that's my experience of it. So that was the conclusion. And so this is just to finish. I think this is a highly panpsychist model. It's even worse than usual. I mean, panpsychism says usually that consciousness is everywhere. Well, in the beginnings of this, there is no where. There is no background space-time or anything, which is usually considered to be good in quantum gravity. A problem is when you have to start with some notion of space. Now, here don't start with anything. The spaces that emerge somehow emerge as that space S. And so Bob would be this what we would call the narrow qualia. Then you take disjunctions of those, you get higher and higher up in the order, have these computations. At some point, you get the more atmospheric version of I feel anxious or in a good mood, or something insightful like Bob thinks, therefore he is. He is excited at that moment. That's already sophisticated. That results from a lot of thinking and a lot of insight, and it emerges as. And of course, you've got Bob's sense of self 1B. And then way above that, it's the top of all Q, which the enlightened quality, which could become Bob or anything else. And I don't know what this means, but I see it as very philosophically interesting. Should I stop? Right. Yeah. So, okay, you'll have the slides. There's some stuff here. There's questions and plans for next week. And well, thanks.
Yeah. Question again, I saw this through. Right, then I'll start from 10:50. Now I start on the start. Good, good. That was my hope. Yes. I'll try this. Okay.
The idea was that we need to find this logical sense. We don't have logical use. These are not only the homological process. And in this space, it's a superior, so there are no why not? Okay, because when I don't know.
Basically, it's like, it's, once I look at now, subtracted by, this. Should I use it as rules for this? For the species might be, yeah. So I should not be using the variance. So here, I should entropy opposite. So here the covariance should be CT. But the computation of actual seems to.
But it's also a problem.
Yeah.
And then I did there was one name song. I sometimes put
I'm also.
It's just please have please have some rest. I can say this. Oh, really? Yeah. But it comes out of this. So find this relationship if it is fine. House. I think having terms of preservable property. Thank you. Yeah. Now what happens? I think so. It's shaker. Do you need this one? So for farming, there will be a subset.
Is it connected?
And I can say, well, instead of taking the, I consider a subset.
Oh.
I'm just throwing away all this in there. Suppose that for all the targets in the universe, all the experience of reality, that's a reality we experience. There's nothing else. Now, suppose you have property inside, which contains, which are
No.
like Qualia.
How do
So we would be talking about two fictitious property, which cannot be distinguished by
nomenclature?
So you have a language that contains later. So what? You want to take some things. You can.
前回これ使ったんだっけ？
うん、でも
あ、てか、俺が
そうそうそう。
シェアしたんだ。
そうそう。それできる。
だから。
な、普通のビット番号覚えてるんですよ。
覚えてない。なんか、あれに、土屋さんが火曜日にくれたやつ、再び招待してくれてもいい？
これそっちのオーディオですね。
はい。
Yeah, I mean, logic is something, supposition logic is something that you build out in.
で、シェアしてる。
Junctions, et cetera, so you have
Stay on
language of the first logic. Depending on the type of logic, you can have a negation.
そっちのオーディオ使う。いや、そこで喋るんだったらそっちの。いや、
From this, you can prove that and conduct the very equivalent logistic equation, so you know. Yes. Our null implication is what's equal, equivalent to non-equal. It's called non-phrase logic, transform logic. The inclusion of alpha very fine.
Okay, we will start.
My next, if you'd like, I'm sure.